Hello. Um, Today I will talk about the chromatography mass spectrometry. First, the device consists of a mass spectrometer through an interface in GC chromatography. The sample is separated as it passes through the gas chromatography. Carrier gas such as helium is used as a mobile phase, and the lead and blue components are separated as they pass through the stationary phase of the column. Looking at the chromatogram, you can see that the interaction with the stationary phase is higher in the lead component. And this is the configuration of the GC. The carrier gas is contained in a gas cylinder and the sample is injected through the injection port. The sample and carrier gas pass through the column, and the temperature can be controlled through the column oven. The separated sample move to the detector and the peak appear. The following is the configuration of mass. The separated sample can be analyzed through mass spectrometry. It is ionized by the ion source and analyzed through the mass analyzer. In GCMS, ionization is usually done through electron ionization. High energy electron of 70 voltage are emitted through thermal emission from the filament. The vaporized sample collides with high energy electron, generating positive ion in which the electrons of the molecule are removed. During this process, the molecule itself is broken to form a smaller ion, and the unique fragment ion pattern is generated depending on the chemical structure of the molecules. These ions are detected according to their mass to charge ratio through the electric and magnetic field of the mass spectrometer. The carrier gas is mainly hydrogen, nitrogen, and helium gas and must satisfy the condition of inactive, pure, and dry. And the inlet is where the sample is injected. Our lab has two inlets, pyrolysis and Pergent lab. When a sample is burned at a high temperature, various reactions occur. And pyrolysis is a method that uses the gas released by the sample. Looking at the EGA thermogram, the gas released is expressed as a peak at the temperature increase. There are two main methods for analyzing pyrolysis. First, EGA uses an empty column to check at what temperature the sample releases gas. So two peaks are observed in the thermogram. For example, if you think about analyze a polymer, the peak found at a low temperature will correspond to the additive peak, and the peak found at a high temperature later correspond to the polymer peak. With this temperature range, you can use it for analyze such as single, double, and hot cut to check the components corresponding to each peak. And this is how to set the GC method. You can set the column here. Uh, Column you can currently using through the set button. And you can set the separation by increasing the temperature in here. And this split ratio, the split ratio is the ratio at which the sample is injected. If it is 100, a small amount is injected, and if it is 1, a large amount is injected. So you can adjust it. And for the best method, you can set the analysis time, time and M over Z range. You can set the analysis time to the same time set the GC. In here. And after saving the set method and enter this method to the batch. Then setup is complete. Next is pyrolyzer method setup. This is for EGA analysis, and you can change by clicking this button. In EGA, you can set the temperature range to monitor 100 to 800. And for double shot, you can set the temperature range found in EGA. TD is usually a process to check the additive. The analysis is conducted by gradually increasing the temperature from the initial temperature. And PY is a process to check polymer and analyze the material produced by briefly applying high temperature. So in this method is a method that raises the sample from 100 degree to 380 degrees in the TD process, and then applied 650 degrees in the PY process for 1 minute. After saving this method, click the button above to open the batch file. Click here, then this pop-up is appeared. You can insert the cup number by clicking the number shown in the picture. Click number, then this cup number is inserted. And because this method is double shot method, so 2 line is inserted at once. So this means that sample number 1 analyzed by TD1 and PY. And after Sample 2 is analyze TD and PY. After setting it like this, click Run in GC and pyrolysis at the same time to process with the analysis. And next, Young will do
Yeah, I explain about the Poison trap. This is a schematic diagram of a Poison trap inlet. When the sample tube containing the sample is inserted into the device, the sample is pressed and trapped as a gas in the PAT, the primary absorption tube section for primary absorption. It is then transferred to the SAT through the transfer line, where it undergoes secondary absorption. After that, the temperature is quickly raised to dissolve the substances, which are then introduced into the GC here. This is the method setup screen for the Persian trap device. There are 6 storage slots for method A to F, and slot Z is reserved for the final end method in the analysis sequence. Please do not modify the Z method and use it as it is currently saved. Each method allows you to set parameters. Each method allows you to set parameters such as duration for each step, split ratio, and temperature. The steps from load to present trap are preparation stage before sample injection. The time setting for the purge and present trap process are particularly crucial. You need to set the temperature and duration for trapping. Typically, a heating time of 15 minutes is sufficient to analyze most substances. Therefore, this is recommended to initially set it to 15 minutes and then adjust the time or temperature as needed. And the standby step allows the system to stabilize, and the desorption step transfers the adsorbed gases into the GC. The default desorption time of 3 minutes is sufficient. Therefore, the actual GC analysis begins with the analysis step. This time should match the GC runtime. Here, GC runtime. And the split ratio determines how much of the sample is introduced. The split ratios are preset in a library by the instrument manufacturer during installation, so users only need to select a ratio from the stored options on other screen. This PAT temperature refers to the oven temperature at the primary absorption sites, and this cryo is the temperature used during absorption at the secondary absorption sites. Additionally, you can set the temperature for transfer line, SAT oven, and needle. These parameters should be adjusted based on the characteristics of the sample being analyzed. Once all method settings are configured, press and hold the green right button for 3 seconds to save this one. And since our laboratory device is equipped with an auto sampler, we also set up the sample analysis batch. Sample number represents the analysis sequence, and rec number corresponds to the location number of the sample tube. Rec number starts at 0, but we do not use rec number 0 for samples. Rec number 0 is always used as a blank, meaning it contains only the sample tube without any actual sample. In the file field, you enter the alphabet of the method saved in the earlier setup here. In this batch, you can see that rec number 0 is analyzed first to obtain blank data. Then the samples in rec number 1, 2, and 3 are analyzed sequentially. Blank data is obtained between samples by analyzing rec number 0. And at the very end of the sequence, rec number 0 is analyzed again using the Z method to obtain blank data. Once the batch setup is complete, press the Start button to begin the analysis. That concludes my explanation. Thank you.
Thank you so much, both of you. If anybody has any question which they want to ask, kindly ask them. I have a question. Question about split ratio. The definition of the explanation of the split number ratio.
Sorry,
Split number.
split ratio.
Yes, yes. What is that?
Split ratio has many options in this device. Split ratio means how much you put the sample in the device. So normally, we do not put all the sample first time because the device can be pollution, 맞나? Getting dirty. So we first put the little amount of sample, and if you cannot get the meaningful data, and you increase the amount of sample. Understand?
Yes, thank you.
Jungwon, I have a question.
Mm.
Why do we need two types of adsorption here? I mean, the primary adsorption and the secondary absorption. What are the purpose of these adsorptions here?
That's because before we introduce the sample in GC, we need to remove the other materials. and you can get the more clear sample and more concentration sample.
Okay, thank you so much. If there is no other question, I will end this meeting. And at 2:30, we will go to GC room and we will have some hands-on experience for using pyrolyzer and Purge and Trap.